Hello everyone, I am here to present my review on a research paper named Blockchain Power Parallel Helical System based on the ACP approach. To improve the accuracy of diagnosis and effectiveness of treatment, a framework of parallel healthcare systems (PHS) based on artificial systems, computational experiments, and parallel execution (ACP) approach is proposed in this paper. In addition, authors combine the emerging blockchain technology with PHS via constructing a blockchain linking patient, hospitals, health bureaus, and healthcare communities for comprehensive healthcare data sharing, medicinal records review, and care auditability. Finally, a prototype named Parallel Gout Diagnosis and Treatment System is built and deployed to verify and demonstrate the effectiveness and efficiency of blockchain powered PHS system. Introduction. Although smart healthcare systems have made an impressive progress in the recent years, situation in practical application is still far from the ideal. On one hand, despite most doctors, especially the expert doctors, have a good knowledge of their own fields, more and more diseases require cross-border medical knowledge of different experts. Thus, it becomes necessary to have them work together using technological means. On the other hand, due to regional and individual differences among the patients, demand for precise medical care, personalized diagnosis, and treatment are increasing. So this paper proposes a framework of parallel healthcare system based on artificial intelligence, computational experiments, and parallel execution approach. First, an artificial healthcare system is constructed to depict and model the patient's and doctor's static and dynamic features is called as descriptive intelligence. Secondly, by adding different types of diseases scenarios in AHS, computational experiments are used to test and evaluate, thus to achieve predictive intelligence. Third, the final regime is chosen to recommend a list by the expert parallelly executed in both AHS and the actual healthcare system to realize the prescriptive intelligence. Framework of parallel healthcare system. From the perspective of modeling, the PHS consists of physical healthcare system and a software-defined artificial disease diagnosis and treatment system. The physical healthcare system includes the real doctors and patients. Correspondingly, the artificial system includes the software-defined doctors and patients. Similar to a real doctor, in AHS there are three virtual ones. The descriptive doctor is an integration of medical knowledge and clinical experiences from real doctor. The predictive doctor is an ideal doctor who possesses the perfect medical skills and comprehensive medical knowledge. A prescriptive doctor refers to a set of optimal artificial doctors obtained by experimental verification based on the different effectiveness of therapeutic manners. The artificial patient is built by recording the biological characteristics, social relations, and environmental characteristics of a real patient. The descriptive patient is data-driven agent regarding the information of the real patient along with the health information, including his/her medical records, histories to, histories to allergies, and genetic test reports. The predictive patients are different versions of patient of whom the artificial doctor can conduct various kinds of diagnosis and treatment experiments. The prescriptive patient is a patient receiving the optimal healthcare and reaching the expected goal of treatment effectiveness before applying to an optimal scheme treatment to the real doctor. Computational experiments. The medical computational experiments in PHS are mainly used not only to make the most reasonable diagnosis, but also to propose and evaluate the potential treatment of schemes for a particular patient through knowledge, reasoning, and the other way computable. The diagnosis computational experiments will be carried out under the principle of evidence-based medicine, which combine the clinical advice, personal experience, and real condition of the patient. The artificial doctor will learn certain diagnosis standards in medical publications for each existing disease, learn the empirical diagnosis knowledge from large historical cases, and also learn the methods of different diagnosis and evidence-based medicines. To achieve the diagnosis process, the artificial doctor will create To achieve the diagnosis process, the artificial doctor will create a scheme on the present system, medical examination details, past medical history, and family medical history, and other information from descriptive patient. Later, the artificial patient and doctors will use corresponding diagnosis knowledge to infer and compute the probability of related disease. In many cases, a patient may suffer from many diseases, especially the elderly, and there is mutual relationship between various diseases. Thus, artificial doctors will learn from the diseases and find a probable solution to the diseases. Then the predictive doctor will apply different treatment schemes to various predictive patients that is derived from the real patient and simulate the compute effectiveness of different treatment schemes. The treatment computational experiments are based on the real doctor scheme principle and adhere to the idea of treating different diseases with the same origin and multiple diseases with the same treatment. Execution. The parallel execution mainly consists of two aspects as follows. The first aspect is a parallel execution between the real doctors and the artificial doctors. On one hand, when artificial doctors conduct the diagnosis computational experiments and make the disease diagnosis, the real doctor will confirm the result through interaction with the artificial doctor and make eventual diagnosis. On the other hand, when artificial doctor choose the best treatment scheme, the real doctor will give his opinion about the result and give eventual treatment to the real patient. The second aspect is that the parallel execution between prospective patient and real patient. The prospective patient will continuously monitor the changes of all biological indicators of the real patient. Besides, the prospective patient will also guide the real patient to receive treatment based on the optimal therapeutic regime calculated previously. Conclusion. In this paper, authors present the framework of blockchain power PHS based on the ACP approach. The PHS use an artificial system modeling to simulate and represent the actual healthcare scenarios. Then training and evaluation of various disease diagnosis and treatment schemes are performed through the computational experiments. Through parallel execution between the actual and artificial healthcare systems, the accurate forecasting and guidance of the disease diagnosis and treatments are realized. Next, authors have reviewed the application of emerging blockchain technology in the healthcare field and present preliminary prototype system for proposed parallel execution framework called PGDTS, Parallel Gout Diagnosis and Treatment Systems.